Hello, this is Dr. Eddie Morgan over at Clovis East High School, ready to help you with your homework again. We're looking at Math 1, Worksheet 5.5 tonight. Remember that every problem on the homework help mirrors a problem on your homework. So if you're having a problem with just one or two problems, find those problems here, fast forward, and we should be able to help you out. Let's get started. The first set of problems asks us to determine whether each sequence is a geometric sequence. And then for each one of these geometric sequences, find the common ratio. To put this in perspective, we have to remember that when we were looking at linear equations, we also looked at what was called arithmetic or arithmetic sequences. And in those cases, you might have a sequence like this. And you notice that it went up by a number. It was always changing by a number. And the result was we had what was called a common difference. Because if you took two successive terms, like 5 minus 2, that was your common difference. 8 minus 5 is 3. Each time you subtract the 2, you get the same number. Now, in a geometric sequence, we have something different. In a geometric sequence, we get something a little different. We start with 2 here. We might go 2, 4, 8, 16. And we notice instead of adding a number, it's being multiplied by a number. And in our case, then, what we have is a common ratio. So we take the first two terms, 4 and 2. Well, 4 divided by 2 is 2. And likewise, 8 divided by 4 is 2. And so we have a common ratio. And that's the main difference here as we get to geometric sequences. So as we look here, we're looking to see, is there a common ratio? And I look 4 and 12, I say, oh, I can multiply that by 3. Now let's see if it works for the next one. 3 times 12, yep, that's 36, and 3 times 36 is 108. So we've decided this is a geometric sequence. And what's the common ratio? Well, take the first two. 12 divided by 4 is 3. 36 divided by 12 is 3. And 108 divided by 36 is 3. So that's my common ratio. In the next one, you may go, well, I don't see a multiplication. They're getting smaller. Well, you might start here by doing the common ratio. See if there's a common ratio. Notice here that 5 divided by 25 is 1/5. And that at the same time, 1 divided by 5, the next two is 1/5. And then finally, 0.2 divided by 5 is also, that's 2/10 or 1/5. So there's my common ratio. So what I'm actually doing here, I could think of it as dividing by 5, but I'm going to say it's multiplying by 1/5. Remember that dividing by a number is the same as multiplying by the reciprocal. So dividing by 5 is the same as multiplying. So once again, this is a geometric sequence. The difference here is the first one is multiplied by 3. The second one is divided by 5, but I can write that as multiplying by 1/5. Continuing on, let's look at determining, we're looking to see, is this a geometric sequence? And if so, find the common ratio. Well, let's just start by finding if there is a common ratio. So when I look at the first one and I look for the common ratio, I'm going to compare successive terms. So to begin with here, 7 divided by 10, all right, that's one ratio. Let's go to the next one. Does that equal 4 to the 7? And the answer is it doesn't. And it certainly doesn't equal 1/4. So notice there is no common ratio. Okay? So we would have to conclude that this is not a geometric sequence. What kind of sequence is it? Well, if I look up here, 10 to 7, it goes down by 3, and then it goes down by 3 again, and then by 3. This is one of those arithmetic sequences. It doesn't have a common, it has a common difference of -3, which makes it an arithmetic sequence that we studied back in Unit 3, I believe. Okay, let's take a look at the next one. Number 4, look at our common ratio, see if it has one. So we have 7.5 divided by 2.5, our first two here, and that is simply 3. We go to the next one, 22.5 divided by 7.5, and once again, that's 3. And lastly, 67.5 divided by 22.5, that's 3. So we have a common ratio of 3. In other words, this is simply being multiplied by 3. So as a result, we can declare this is a geometric sequence. Problem 5 and 6 asks us to write the explicit and the recursive formulas for each geometric sequence. Let's just do a quick little review. You remember for the arithmetic sequence, we had the explicit look like this. We said that the nth term equaled the first term plus n minus 1 times the common difference. The recursive form said that the nth term equaled the one before it, the n minus 1 term, plus the common difference. Notice the two things you needed to know for each of these was what's the first term and what's the common difference. Now, as we move over to geometric, it's very similar. If I look at the explicit is written this way. The nth term equals the first term times the common ratio now to the n minus 1 power. You can see some similarities. First thing to notice is they changed terminology on us. In the explicit, we use this to mean the nth term. They use a kind of a functional notation. They call this the nth term. This chapter, we're using the kind of a subscript term to say a to the n term, and we mean the same thing by both of them. Mathematicians just have various ways. But notice here in the arithmetic, we started what's the first number, and then we add the difference. Here we start with the first number, and then we start multiplying by the common ratio. The recursive simply says the nth term equals the one before it. Again, notice a very clear similarity times whatever the common ratio is. So once again, the two things you have to know is what's the first term and what's the common ratio. If you can determine those, then you can write either of them. So we go to number 4. What's the first term? Well, the first term is 4. So I'm just going to write down here that the first term equals 4. And then what's the common ratio? Well, if you look there, you can see that the common ratio, 12 divided by 4, is 3. In other words, each of these is being multiplied by 3. So now we can write our equation. To write the explicit, look down here, the explicit term over here, here's my explicit, a to the n, the nth term, is equal to the first term. So I put in the number 4. And now next is my common ratio, 3. And that is to the n minus 1 power. So there's my explicit ratio. For the recursive, again, very simple. We look here. Here's my recursive. So I have a to the n equal a to the n minus 1 times the common ratio. And that's our two answers. All right? So let's look at number 6. Our first term is 3. So I'll write down here a1 equals 3. What's it being multiplied by? Well, notice this one's being multiplied by negative 2. And then again, negative 2. And again by negative 2. Put a little parentheses there so we don't confuse ourselves. So my ratio is negative 2. So now let's write our explicit. Again, these are really simple. You got to know the formula and know where to put them in. So I'm going to write in an equals, and then my first term, and my first term is 3, times, and then my ratio is minus 2. I put the minus sign there, the parentheses there, so I don't get confused and think I'm subtracting, to the n minus 1. You'll notice I wrote it in red and blue simply to show you that the red part of these sequence formulas don't change. You're only substituting those two. Likewise with the recursive, an equals the previous one, a to the n minus 1, times the common ratio. And again, just like before, we usually will write down here, if we're only writing the recursive, we'll usually write down, oh, by the way, a to the 1 equals 3. And so this is the answers for number 6. All right, let's jump into number 7. We want to write the explicit and the recursive formulas for each geometric sequence. So first of all, our first term here, the first term, 384. What's our common ratio? Well, our ratio is going to be 96 divided by 384, which is going to be 1/4. You can see this again here. So this is times 1/4. And so likewise, 24 divided by 96 equals 1/4. And 6 divided by 24 equals 1/4. All right? So those are very simple. And now we write our formulas. Remember our explicit formula. Let me just write them over here to remind you. Our explicit, a, the nth term equals the first term times the common difference to n minus 1. And the recursive, the nth term equals the previous term, the n minus 1 term, times r. And then we would state that a1, whatever a1 is. So in our case here, our explicit term is going to be a to the n equals the first term, and our first term was 384, times the common difference, 1/4, to the n minus 1 power. All right? Our recursive is going to be the nth term equals the n minus 1 term times the common difference. And so there's the two explicit and recursive formulas for number 7. So let's move to number 8. Number 8, again, the first term is 100. And our common ratio is, always remember when you're doing this, it's the second one you put on top. So it's 20 over 100, which equals 1/5. And by the way, that's the same here. 40 over 20 is 1/5. And 4/5 divided by 1 divided by 4 is 1/5 as well. So there's our common ratio. So now we can write our terms. Explicit, a to the n equals the first term. First term here is 100 times the common difference, 1/5. Put that in parentheses, n minus 1. Remember again, just like with the geometric, you're thinking, why is it n minus 1 and not n? Well, it's because the first term is not multiplied yet. So if I put n equals 1, 1 minus 1 is 0, and then 1/5 would be 0, and I just have my first term. My second term becomes the first one that's multiplied by the common ratio. All right? Let's write down our recursive. A to the n equals a to the n minus 1. Remember, these are subscripts, not exponents, times the common ratio, which is 1/5. And then we also state that a1 equals 100. And so there's the answers for 7 and 8. Our last two problems in this section, again, we're writing the explicit and the recursive formula. Just to remind you, if you're just skipping into this problem, the explicit says that a to the n equals the first term times the common ratio to the n minus 1. All you have to find is what's the first term in the common ratio. Likewise with the recursive, the nth term equals the previous term times the common ratio, and then we typically write whatever the a1 is. So again, all you have to do is find what's the common ratio and what's the first term, and you can write either of these. So let's start over here. Let's find our first term is 6. And then we look up here and say, what's our common ratio? And I'm looking here and saying, oh, this is being multiplied by minus 3. And you notice they're each being multiplied by minus 3. If you're not sure about that, you do this. You take minus 18 divided by 6, and you get minus 3. You can take 54 divided by minus 18, and you get minus 3. You can take negative 162 divided by 54, and you get minus 3. Notice each time we're just taking this, dividing it by this dividing it by this dividing it by this. So there's our common ratio. So now we can write our two terms. Our explicit, we have a to the n equals the first term. Our first term is 6 times, we're multiplying this by minus 3, that's our common ratio, to the n minus 1. Again, I wrote it in different colors so you'd see that the blue is what we're substituting. The other parts of this are going to stay the same no matter what you have. Our recursive simply says that the nth term equals the n minus 1 term times the common ratio. And then we usually always state and a1 equals 6. So there's our answers for 9. 10 is an interesting one because you can immediately see what's happening each time. It's just being multiplied by 1. Okay? So our first term is 7, and our common ratio, 7 over 7, is just 1. So our explicit sequence is going to be a to the n equals the first term, which is 7, times the common ratio, which is 1, to the n minus 1 power. Our recursive says that the nth term equals the n minus 1 term times 1 And then remember that A1 equals 7. All right? So those are fairly simple. You do have to remember what the formula is for the explicit and the recursive, and then simply find the first term and the common ratio, and these become very simple problems. Number 11 is an error analysis. So what I usually do with error analysis is I just work the problem and see what they did differently. It says that a friend says that the recursive formula for the geometric sequence is this. Well, you remember the recursive formula simply says that the nth term equals the n minus 1 term times the common ratio. And if you look here, you can see that the first term is 1, and the common ratio is times minus 1. All right? So if I'm writing the recursive, I would simply write an equals a to the n minus 1 times negative 1. That's the recursive formula. However, our friend wrote this. A to the n equals 1, our first term, times negative 1 to the n minus 1. So what did he write? Well, he wrote the explicit formula. You remember the explicit says that the nth term equals the first term times r to the n minus 1. So the mistake, he simply wrote the wrong formula. He wrote the explicit not the recursive. All right, I hope this has helped you with your homework tonight. Have a great day.